सर जब करंट सेम रहे तो
Current should be same actually, not equal. It should be same current should flow. Okay, when do
yes,
you call two elements in parallel?
वोल्टेज सेम रहना चाहिए, वोल्टेज
No,
सेम.
yeah, voltage will be same, as well as the two both the ends of one element should be connected to both the ends of other element. Okay, we have seen some good amount of problems, right? Series, parallel combinations and all. Okay.
Yes,
Yeah, and we have seen dependent sources, independent sources, current source, voltage source. Okay, and what else we have seen? We have seen star delta transformations. We have seen Wheatstone bridge, right? What is a Wheatstone bridge? Why is a Wheatstone bridge used?
Or finding unknown resistance value.
To find the unknown value of unknown resistance, right? When you call a bridge balance, if I see this is my bridge, when do you call the bridge as balanced?
sir R1 by R2 is equals to RF by R3.
Yeah, okay. R1 by R2 is equal to R3 by R4. This also can be written, or R4 by R2 is equal to R3 by R1, or VB is equal to VD. When the potential here is equal to the potential here. Okay, when the potentials at these 2 points are equal, what can we do? There is no current flowing. The current flowing here is 0. In the balanced bridge condition, the current in the central limb will be 0. Okay, this should be remembered. Okay, this is so. Next topic: linear and non-linear elements. Okay, an element is said to be linear when its VA characteristics follow only one equation of straight line. Only one equation of straight line. Let me underline this: only one equation of straight line, and it should be passing through origin for all time. So if I say this is my VA characteristics, these are my VA characteristics. So it's better for everyone to what you call write down the running notes. Okay, even if you have the recordings and all, but it's always good to practice having notes, handwritten notes for all the exams. Okay, so V and I. So if I see the V and I here, it is the equation can be this is only only one equation of a straight line, and this is passing through horizon. So this is a linear element. Okay, linear element is one which has whose VI characteristics follow only one equation of a straight line, and it should pass through horizon for all the time. Okay. And if you see this, this is also a straight line equation and it is passing through origin. So even this is a linear element. Okay. Linear element, what are the examples? Resistor is a linear element under constant current and temperature. Okay. Diodes, all these are non-linear elements because they don't follow a straight line equation. Okay. And if you see this, this is a straight line and it passes through origin, but there is not one equation. See here up to 0, this is not this is 0, right? So this is not a one equation for all the time. For all time, it's not valid. So this is a non-linear element. Okay. This is about linear and non-linear elements. Linear, when do you call an element as linear? When its VA characteristics follow only one equation of straight line and it should pass through origin. And next, active and passive elements. See, if I'm going fast, I want you to interrupt me and ask me to slow down. Okay. Active, and because this is a online class, I don't get the feedback directly. I can't see your faces, so it's better if you can raise your hand, or if you can message me, or you can directly talk to me. Okay. Active and passive elements. Again, active element is one which delivers net amount of power to the circuit. Otherwise, it is called as a passive element. Okay. So what do you mean active and passive elements? We have seen active elements are nothing but your sources. Passive elements are energy consumers. Okay. So if you see this, these are the VA characteristics. VA characteristics. So active element is it delivers net amount of power. That means if you can see, this is your positive slope is passive element, negative slope is active element. Okay, positive slope is passive element. So if you see, this is plus V by plus I. This is, sorry, plus V by plus I is positive slope. Positive slope is passive element. Okay, so what is this can be a resistor. So resistor is a passive element. So if you see this here, voltage is positive plus V by minus I. So this is negative slope, is an active element. Okay, again this is a positive slope, passive element. Okay, so sometimes in gate or like even in your what you call exams, competitive exams, you will be given an element and its VA characteristics. You need to find the what you call type of element. Okay, you need to find the type of element. Next, if you see unilateral and bilateral element, what do you mean by unilateral and bilateral? Unilateral is bilateral, which offers same impedance even when the direction or the polarity of voltage or current get reversed. Otherwise, what you call otherwise unilateral. Okay, so if you see every linear element, okay, let me see this, offering same impedance if the direction or polarity gets reversed. If V plus V, the slope will be V by. Here if I see, this is minus V and minus I. So this will be V by I, impedance here, impedance or resistance V by I. So if the magnitude of V by I here and here is same, if the magnitude with the directions, if they are same, then you can call it as a bilateral element. Here also same. If the values here are same, if it is 3 and it is also like 4, it is minus 4 and minus 3, then it is a bilateral element. So directly from this, it is a unilateral element. Okay, so you can generalize this. Every linear element is a bilateral element, but converse is not true. Okay, every linear element is a bilateral element, but converse is not true. Am I clear so far? Next, time variant and time invariant. If the VA characteristics changes with time, it is called as time variant. If doesn't change with time, it is called as time invariant. Okay, so if this is the this is for T1, T2, and T3. This VA characteristics of the same element. If these are the VA characteristics of the same element at time T1, T2, T3, this is called a time variant. Sorry, it's getting zoomed in. So it is called as time variant. Next, so find the nature of the following elements. If you can see in the first one, directly it's a linear element. and is a bilateral element. When you say it's a linear element, it's directly bilateral, because as I told you, every linear element is a bilateral element, but converse cannot need not be true. Okay, every linear element is bilateral, but converse is not true. Okay, so is it active or passive? The slope is negative, so this is, sorry, slope is positive, this is passive element. Passive element. Okay. Okay, linear, passive, bilateral element. So if you see this is again not non-linear directly, not one equation. Okay, non-linear, and it is unilateral. See, active plus any is equal to, this is a negative slope, this is active, and positive slope, and it is positive. So active, so this is an active source, sorry, active element. Okay, active, non-linear, and unilateral. So again, if you see this is again non-linear. Okay, non-linear, again passive, sorry, active. Here negative slope, active, and unilateral. Okay, you can stop me if you want, if you have any doubts. This is again non-linear because not one equation. Yeah,
So how the previous one is active?
active because see the slope here. If can you tell me the slope? This is minus v. Sorry, this is minus v and plus I. Slope is nothing but v by I, right? Minus v by plus I is negative slope. Negative slope, I told you. If you see, so negative
Yes.
slope is always active. Okay.
Yeah, but the upper part is has having the
Yeah,
positive sign.
that's the thing. If you see here, active plus anything is active. Active plus
Okay.
passive,
Okay.
okay, is an active element. So this is an
Okay.
active, non-linear, and unilateral. Okay,
Yeah.
and this is non-linear. Okay, this is non-linear because this doesn't have only one linear. It should have only one equation. After this, the equation changes. So this is non-linear, and this is passive. Okay, passive and bilateral. So this is again non-linear, passive, sorry, active, and unilateral. Okay, this is non-linear, and again, so this is a positive slope, so passive and unilateral. Okay, this is okay, everyone. You can check it once again. If you have any doubts, you can ask me. This should be clear because many times you will be given the graph of or the VI characteristics, and you have to find what type of element is it. Okay, you need to say whether it's a passive or active element, unilateral or bilateral element, or a linear or a non-linear element. Okay.
Sir,
Hmm.
in
Yes.
the second and the third diagram, how can we say it's unilateral? Like, what if the slope is the same, even though if it's negative, but the slope is the same? Can we say that it's bilateral then?
No, actually bilateral in the sense the voltage and negative voltage and current should be. We have to see the if I see this point, I have to see the fourth quadrant. If I see this point, I have to see in the this quadrant. Both voltage and negative should be opposite. Okay.
All right.
The case. If I consider the impedance here, the impedance here is 0. If I consider the impedance here, the impedance here is 0. So that is why these two are not bilateral. That's why these two are unilateral.
All
Okay.
right, sir. Okay, sir.
Yeah. This is about the topic. This is a small topic. I just want to give you the idea of unilateral, lateral, linear, non-linear, because these type of questions are coming. Okay, let's do some more problems. Okay. Okay. So everyone, I want to do these problems. Find the currents I1 and I2 in the following figures. Find the currents I1 and I2 in the following figures. So I want you to try these. I hope everyone are ready with your pen and paper. Even if you have calculators, that would be better. Answers. I'll solve one for you. I want everyone to try the other one. Okay, I'm solving this one for you. So, so we have seen KCL and KVL, right? What do you mean by KCL? KCL, definition of KCL. Kirchhoff's current law. Yeah.
Sum of incoming currents at a node should be equal to the outgoing.
Currents. Okay, right? So so at any node KCL is valid. At any node in the circuit, the KCL is valid. So what I want to find, I want to find the current I1. And remember, every current that leaves the circuit will should come back to the source. Every current that leaves the source should come back. The same current will come back to the source. So I want to find the value of I1 and I2 here. I want to find the value of I1 and I2. Everyone, you can view the circuits, right? Everyone can see the circuits. Are they very small, or can you see the circuits?
It's visible, sir.
Visible, right? Okay. So if I take the this node, okay, or if I take this node, and if I say the current okay, and if I consider this node, okay, let me consider this node. If tell me the incoming currents and outgoing currents at this node. Tell me the incoming and outgoing currents at this node. This is a gate question, not question, direct question. So tell me the incoming and outgoing currents in this at this node. Tell me the incoming currents.
Incoming currents are I2 and 2 amps.
I2 plus 2 is equal to outgoing current is 5 amps,
5.
right? So I2 will be, I2 will be 5 minus 2, 3 amps directly. Okay, clear everyone? After this, come to this node. Come to this node. Tell me the equation at this node. Tell me the KCL at this node. Tell me the incoming currents here.
I1 is equal to 2 plus I2.
Yeah. Yeah. Here we already did the node at this node. What we got? I2 plus 2 is equal to 5. So I2 is equal to 3 amps. Now at this node, I1 is equal to 2 plus I2. So I2 we already know as 3 amperes. So I1 will be 5 amperes. Okay. So this is, otherwise you can directly say if the current 5 amps is coming here, the 5 amps should come from this way. Okay. Okay, you can you understood this, right? If a current is coming 5 amps from here, the same current should be like coming from the source. That's how you can tell I1 directly as 5 amps. Otherwise, you can use your KCL. Okay, so I want everyone to try this problem and find the currents I1 and I2. Find the currents I1 and where is I2? This one. Okay, use your KCL and KVL. Sorry, KCL. KCL is enough. Any answers? Any answers? I'm waiting. Are you trying or shall I do it? Okay, find the equation at this node. Find the equation at this node and find the current here. Can you tell me the current here? This current. If I consider it to be leaving current, can you tell me the current there? Anyone? KCL at that node.
10 amps.
Right, 6 amps is coming here and 4 amps is coming, so this will be 10 amps. The same current is flowing here, 10 amps. And can you tell me what is I1 from this at this node equation? So 10 amps is coming here, 5 amps is going this way, so I1 should be 10 minus 5 amperes. Okay, 10 minus 5 amperes. So if I know I1 as 5 amperes, is I2 here? Node equation. So incoming currents 5 amperes is equal to I2 plus 7. So I2 is equal to minus 2 amperes. Okay. So I2 is amperes, I1 is 5 amperes. Everyone clear? Is it clear? So I want to do the next problem. That's why I want to ask you. Is it clear?
Yes, sir.
Yeah. Okay. So just try to solve this. This is a gate question. I want everyone to draw this problem on your paper and try to solve this. Any answers? So again, what is KVL? What is KVL? Everyone look here. You can solve the next problem. Let me solve this one for you. So KVL is I hope everyone are busy working out the problem. So KVL is nothing but the voltage drops across any closed path is always 0, right? The voltage drop across any closed path is always 0. So if you see this problem, R is given as 1 ohm here. R is given as 1 ohm. I1 is given, I4 is given, I5 is given. So you need to comment about I3 and I6, or if the data is insufficient, you should tell them. Okay, I2, I3 and I6. Okay. Okay, so if you see this, this is a closed path. This is a closed path. If you like start from here, okay, the what you call voltage drop across that circuit should be 0. Okay, so let me write the voltage equations in the loop. So if I start from here, this point, let me call it as A. If I'm starting from A, I need to get back to A. Need to get back to A. Okay, so if I write the voltage equation here, so what will it be starting from A? So I3 into R plus the current here, I1. I1 into R plus here is I2 into R is equal to 0. Is equal to 0. So I3 is not given. I1 is given as -2. So R is also 1 ohm. So I3 plus I1 is given as 2 amperes plus I2 is also not given. I2 equal to 0. So I have an equation I2 plus I3 is equal to -2. Okay. So again, if you see from this, let me write the currents here. I1 is given as 2 amperes. I1 is given as 2 amperes here. So I4 is given as -1 ampere. So can you tell me what is I2 here from this node? So I1 2 amps is coming at this node and 1 amp is going. If this is -1 amp, this should be 1 amp. 1 amp is going, 2 amps is coming, 1 amp is going here. So I2 should be equal to 1 ampere, right? Right? And again, I5 is -4 amperes. So 1 amp is coming here, -4 is coming from here. Otherwise, 4 is going from here. 4 amps is going, 1 amp is coming from here. So this current should be 3 amperes. Or I3 is -3 amperes. Everyone clear? I3 is minus 3 amperes. So I have I3 as -3 amperes. So I can solve this as I2 minus 3 equal to -2. So I2 is equal to 1 ampere. I2 is 1 ampere and I3 is equal to -3 amperes. Okay, and I need to comment about I6. So can you tell me what will be I6 at this node? So 3 amps is going this way, 3 amps is going this way, and 2 amps is going this way. So how much should this be? I6 should be 5 amps. I6 should be 5 amps. Option A. Are you able to understand this? You should apply KCL as well as KVL in this problem. You have to find the node currents at every currents at every node and also the loop equation. Okay. Okay, is this clear or shall I explain it again? Is this clear?
Yes, sir, clear.
Clear, right? Moving ahead. So try this question, please. I want to enlarge this previous screen. Okay, is it clear now? Okay, I'm moving. So now this question. Find the current through the 0.03 ohm resistor. So find the current through the 0.03 ohm resistor. This resistor. So everyone try this. I'll give you a minute. I want the answers from you. See, networks is such a scoring subject. Only thing is you need more and more practice. Okay, if you have more and more practice, networks, the questions you get in gate can be answered directly. Actually, you can answer the questions directly. Most of the problems we do as practice, we use calculators and all. In gate, mostly 80% of the questions you don't need to use the calculators. At least from what you call network theory, you don't need to use calculators. At least for 80% of the questions. So do a loop in this, in the center, do the loop and find the current through the 0.03 ohm resistor. Okay, hope everyone is doing. I'm solving it for you. Okay, I want the current through the 0.03 ohm resistor. Let me take this current as X. Okay, X is coming from here. So what will be this current? Anyone? This will be X minus 120, right? X minus 120 amperes. Okay, so if this is X minus 120, can someone tell me what current here? So X is coming here, 120 is going, so this should be X minus 120. Here, everyone look here.
X minus 50.
Yeah, X minus 120 plus 70. So X minus 50. Okay, so X minus 50 is coming from here, 30 is going here. So what will be the current here?
X minus 80.
X minus 80. So X minus 80 is coming from here, 80 is coming from here. What will be the current here?
X.
X. Again, so X is coming from here, 60 is going. This will be X minus 60. Right? So again, here X minus 60 plus 60 X. Okay? Is that clear? So if I take the loop here, but starting from this point, the voltage drops. Starting from this point, tell me the voltage drops if I'm going clockwise direction. Starting from here, X into current into resistance, X into 0.03X plus X minus 120 into 0.01 plus the drop here, X minus 50 into 0.01 plus here X minus 80 into X minus 80 into 0.02 plus 0.02 into X, 0.02X plus 0.01 into X minus 60 is equal to 0. You understood what I did? What all I did? I just wrote down the voltage equations. So the voltage is nothing but current into resistor. So this is my current, X is the current, resistance is 0.03. So X into 0.03X, okay, 0.03X plus current is this X minus 120 into 0.01. Again here, X minus 50 into 0.01 plus x minus 80 into 0.02 plus 0.02x plus 0.01 into x minus 60. So solve this for x. I want answer from everyone. Solve the equation. Only one unknown. Only one unknown. If you have calculators, it's very direct one.
The C 39 ampere.
Yeah, 39 amperes. Okay. So moving on. Again, it's a gate question. Find the value of voltage source E in the following circuit. Find the value of voltage source E in the following circuit. So what we do again, see, if I say a voltage of a node is 10 volts, what does that mean is, it is 10 volts plus 10 volts with respect to ground. Okay, with respect to ground. So with respect to ground, the voltage here is 10 volts. So with respect to ground, the voltage here is 10 volts. That is what it means. Okay, so if I say this is 10 volts, so this is again with respect to ground. Okay, if I say this is V1, this is again with respect to ground. Okay, ground voltage is always 0. Okay, again if this is V2 plus V2 and minus will be at ground 0. Okay, so if I take this loop, I can consider any one of the loops. Any of the loops. I'm considering this loop because all the voltages here in this loop are known except for the E. I want to find the value of E. Okay, except for E, I know all the values of here. So this is a loop. Why? Because this is a loop. Why I'm considering this as loop? This 0 volt is connected here directly. Okay, ground voltage is same. So this is basically connected. So this is a closed loop. I can apply my KVL here. Okay, starting from this point, if I apply KVL, what happens? This is plus 1. Okay, plus E and plus 5 plus 10 is equal to 0. So can you tell me what is E from this? You understand it, right? So this is 0 plus V. You should always write down the first what you call sign you encounter when you do this. Okay, and circle it. Okay, you can actually consider the other way, clockwise or anti-clockwise. I consider the anti-clockwise because it's simple, easier to understand. That's why. So this is plus 1 plus E plus 5 and plus 10 is equal to 0. So E is minus 16 volts. You can do the same here. You can do the same here also. The thing is, you need to first find out the values of V2 and V1. Then you can use the KVL equation here. Okay, you can use the KVL equation here after finding the voltages V2 and V1. Okay, this is a direct question for 1 mark in gate. Okay, is this clear? Shall I move on?
Yes, sir.
Sorry, I was muted actually. So find the equivalent resistances. Draw these circuits in your notebooks and try to solve this. So I'm just zooming in. So this question, I think everyone should be able to answer it. This one. Okay. So these are called as infinite ladders. I'll do the first one. I want everyone to practice the second one. Okay. So this one, I want the answer for this. So this one, I want the answer from everyone. You need to identify what are series, what are parallel. Okay. Any answers? Any answers? Shall I solve it for you or? Yeah, correct. Varun Chandra. Six is the answer, right? So these three are in series. 5 plus 4 plus 3. 5 plus 4 plus 3. 5 plus 4. 9 plus 3 is 12. 12 parallel with 4 is 3. 12 into 4 by 12 plus 3. Sorry, 12 plus 4. 12 into 4 by 12 plus 4. So you'll get it as 3 ohms. So this can be replaced with 3 ohm resistor. So 3 ohms and 3 ohms in series will be 6 ohms again. So this will be 6 ohms. 6 ohms parallel. 3. 3 will be in series with these two. So this will be 6 ohms. So you want me to do step by step, everyone? Is it clear? 6 ohms. Okay. Shall I move to the next question? Or shall I do the problem step by step? Okay. I'm moving on to the next question. Okay. So find the equivalent resistance. This is called infinite ladder. Because this will extend up to infinity. This circuit will extend up to infinity. The same one ohm, 1 ohm. So this will extend up to infinity. That is why this is called as an infinite ladder. Okay. So so how to solve an infinite ladder is what you have to do. So you all know infinity plus 1 is also infinity, or infinity minus 1 is also infinity. So what will we do is we'll make use of this. What will I add? I'll add same network, one more network from this. So if I call this as RAB, so if I add one more branch of this, that doesn't change, right? It will again be RAB. Will again be RAB. So I'll take RAB and I'll add one more branch to this. Okay, one more branch of ladder to this. So this will again be the same. Okay, so if you can see this, these two are in, how are these two? These two are in parallel, right? So parallel, what is the, or I can directly write as RAB is equal to, so this is in series with the parallel combination of 1 and RAB. So 1 plus 1 parallel with RAB. So this is 1 plus 1 into RAB by 1 plus RAB. So I can write it as RAB is equal to RAB 1 plus RAB by 1 plus RAB. So this is equal to RAB plus RAB square is equal to 1 plus 2 RAB. So if I bring this in this side, RAB square minus RAB minus 1 is equal to 0. Clear, everyone? Is it clear till here? So it's an equation of second order, so you know how to solve it. So there are no factors for this. So what I'll do, RAB is equal to minus B plus R minus root of B square minus 4AC by 2A. Minus B is 1 plus R minus root of B square is minus 1 square is 1. B square minus 4AC, 4 into 1 into C is plus 4 by 2A. So 1 plus root 5 by 2 comma 1 minus root 5 by 2. So resistance can never be negative, so this is neglected. So answer is 1 plus root 5 by 2. 1 plus root 5 by 2. Is it clear? Is it clear? Shall I explain it again? I want you all to try the next question. This is clear, right? So try this question, everyone. You want the answer for this? Is it clear? Shall I repeat the problem? Okay. Yeah. This one. I want you all to try this question. The only difference is you have this resistance here. You have this resistance here up to infinity. This resistance. So I want you to solve it. The same method. Any answers? I'll wait for 10 seconds and I'll do it anyway. So again, if I consider the same logic, so this is RAB. Let me call it for simplicity R. This is R again. So R is equal to, these two are in series with the parallel combination. So 2 plus 1 parallel with R. So 2 plus R by 1 plus R. So this will be R square plus R is equal to 2 plus 3R. Okay, 2 plus 3R. So if I bring R's all one side, R square minus 2R minus 2 is equal to 0. Okay, so R will be minus minus B plus R minus root of B square is 4. B square minus 4AC is 4 into 2. Don't know, there is some problem here. We'll go to the previous slide and come. Yeah. Okay. So minus B plus or minus root of B square minus 4 into AC is 4 to 8 by 2A. 2 plus or minus root of 12 by 2 is This is 4 root 3, 1 plus root 3 by 1 plus root 3. Okay, if I cancel the 2's. Is it clear? And I'm neglecting the negative 1 minus 1 minus root 3. This will be neglected. Is it clear? Is it clear? So I want the response. Shall I repeat? Okay, I'm moving on. So this is a again a gate question. Yeah, I want to see if you can answer this. Try to answer this. It's a 1 mark question actually. 1 mark question. So anyone can tell me the answer A, B, C, D. One can directly tell the answer on looking at the question. Answer C. No. Okay, let me solve this. See, these two, if you can see the similarities between these two networks, everything is the same. The RA is all same as RB except for the resistance 1 ohm resistor. Here, there is no 1 ohm resistor. Okay, there is no 1 ohm resistor here. Except for that, RA and RB are same. If you can closely observe it, so I can write this something like this. This is my 1 ohm. This is RB. This is nothing but your RA. So this entire thing can be replaced with RA, because RA is nothing but this. Okay, so now can you tell me RB is RA parallel with 1, RA by 1 plus RA. Is it clear? Am I clear? Shall I explain again?
Clear, sir.
Clear, right? Again, these two problems. So all the resistance in this are R. Find the equivalent resistance between A and B. Okay, here if this one R is equal to 300 ohms, find RAB. These two are different problems. Okay, both are gate questions. Again, any answers? If you are thorough with my previous class, you should be able to answer it directly. Yeah, someone said 100. 100 is the right answer. 100 is the right answer. Okay, let me explain you. I don't know how did you solve. Okay. So this one, if everyone can see, what is this? This is the central part. What is this? This central one. This part. If you can see this, this is a
So Wheatstone bridge.
Wheatstone bridge, right? This is a Wheatstone bridge. If you can see, this is also a Wheatstone bridge. This is also a Wheatstone bridge, and this is also a Wheatstone bridge. There are 3 Wheatstone bridges in this. This is a Wheatstone bridge, this is a Wheatstone bridge, and this is a Wheatstone. Able to see it? There are 3 Wheatstone bridges, right? So whenever you see a Wheatstone bridge, the first thing you have to do is, what will you do? The first thing, whenever you see a Wheatstone bridge, the first thing you should be doing is you have
Look for a balanced bridge
yeah,
condition.
you have to look for the balanced bridge condition. Are all the bridges balanced? Because all the resistances are R, right? Are the bridges balanced?
Yes.
Yes, they all are balanced bridges. Okay, so this is a balanced Wheatstone bridge, this is a balanced Wheatstone bridge, and this is a balanced Wheatstone bridge. So for a balanced Wheatstone bridge, you can remove the central limb because the current flowing in the central limb is 0. Okay, you can remove it. So as the central limb, the current carrying through the central limb is 0. So I can remove this resistance, and this resistance. Now the circuit will become something like this. Otherwise, okay, let me draw it this way. So these are all R's. So any parallel combinations do you see? Series parallel combinations. So if you see, these two are parallel. You can see these two are parallel, these two are parallel, these two are series, parallel, series. Okay, these two are parallel and these two are parallel. So I can write this as, this is 2R, and the last one is also 2R. So again, I have a resistances here. Again, parallel resistances here. So R and R parallel, what is the equivalent resistance? R and R parallel, what is the equivalent resistance? Two equal resistances are in parallel.
R
What is the
by
equivalent?
2.
R by 2, right? So this can be replaced by R by 2, and this is R by 2. So this will become something like this. So I'll draw it here. This is my 2R and 2R. So this is R by 2 and this is R by 2. R by 2 in series with R by 2 is R. This is R by 2 and this is R by 2. Series R. Okay. So again, if you see, these are all in parallel. 2R parallel with R. 2R parallel with R. Sorry, 2R parallel with 2R. Okay. 2R parallel with 2R.
R.
R, right? So you'll be having 3 resistors in parallel, all equal to R. So what is the equivalent resistance? R and R. R by 3. And R is given as 300 ohms. So this will be 100 ohms. Okay. Okay, is it clear, everyone? Is it clear? See, okay, let me tell you one more thing. In Wheatstone bridge, in a Wheatstone bridge, so when the bridge is balanced, what happens? This voltage is equal to this voltage. The potential difference between these 2 points will be 0. Potential difference is 0. Voltage is 0, current is 0. This is a typical case. When the current is 0, you will call it as an open circuit. When the voltage is 0, you will call it as a... When the current is 0, you will call it as an open circuit. When the voltage is 0, what will you call it?
Short circuit.
A short circuit. So instead of opening it, you can directly short it. Okay, in this problem, if I short it, I'll get the same answer. If you try to do this, I can short it and you'll get the same answer. Not only in this problem, for a balanced bridge, you can open this or short this. Okay, you can open it or short it directly. Okay, still you'll get the same answer. Even if you don't open it, if you solve keeping this resistor, you'll get the same answer. Okay. Okay, for a balanced bridge, even if you keep the resistor and solve it by using a star delta transformation or any other method, mesh analysis, you'll get the same answer. Okay, the shortcut is you can directly open them or short them. In this, you have to decide looking at the circuit. If in a particular circuit, if you feel that it should be shorted, if you short it, it will be easier. You can short it. If you feel it is easier if you do it open circuit, you can do it. Okay, so otherwise also, so if you see there is one Wheatstone bridge, so all the resistances in a Wheatstone bridge are equal to R. The total resistance is R. So this is an R parallel with R parallel with R. So you'll get R by 3. Of course, there is an interconnection here. Otherwise, this is a 3 R's parallel direct question. Okay. So understood the logic, right? So that's the logic. You can short it or open it because the voltage between these 2 points is 0 as well as the current. Okay, current is 0 is an open circuit, voltage 0 is a short circuit. Okay, you are able to follow me? I'm moving to the next question. Okay, so this is an unit cube, or sorry, this is a resistor cube. You need to find the resistance opposite for the diagonally opposite sides. Okay. So for all these type of problems, what we basically do is we'll apply voltage source. We'll apply voltage source V, and we'll assume a current of I flowing through this, and we'll find V by I ratio. V by I ratio is nothing but V by I ratio will give you resistance, equivalent resistance between these two. Okay, I want to find the voltage and current ratio. Okay, so I'm assuming a supply of V is applied to this, a current of I is flowing through this. So all these resistances are equal to R. All these resistances are equal to R. So equal resistances. So equal resistances, what we have seen, if I have two equal resistances and the current here is I, what happens? Both are, so what will be the current here and here? Current division rule. If I use current division rule, so these two share current equally, I by 2 and I by 2. Okay, so current division rule, the current here is I into opposite resistance by total resistance. So I into R by 2R. Nothing but I by 2. So the current here is I by 2 and the current here is I by 2. So the logic is if the resistances are equal, the current will be equally divided. Logic is if the resistances are equal, the current will be equally divided. Okay. Okay, so I'm assuming current of I here. So how many branches the current is getting divided? Here, if I assume a current of I and all the resistances from here it is same. Okay, so it should divide into 3 equal parts. It should divide here into 3 equal parts. Okay, so this will be I by 3 and this will be I by 3 and this will be I by 3. So again, this I by 3, this I by 3, if I see, this is going here and it is getting divided into further 2 branches. Okay, further 2 branches. So 2 branches, again I by 3 is divided into 2 branches. What happens here? So this will be I by 6 and this will be I by 6. Okay. Okay, same here. I by 6 and I by 6. Okay, again same. I by 6 and I by 6. Okay. So now what is happening at this point again? If you see this is I by 6 coming, this is I by 6 coming. This will be I by 3. Again here, I by 6 coming, I by 6 coming. So I by 3. Again here. So this is an I by 6 coming and this is an I by 6 coming. This will be I by 3. So here I by 3 plus I by 3 plus I by 3, I. So whatever the current is going, it is coming back. Whatever the current I is going, whatever the current I is going from here, it is coming back. So if I track one of these, what you call current paths, if I track one of these current paths, what will I get? There's nothing but a voltage equation. So from that I should be able to find the V by I ratio. Okay, if you see this, these are all the different current paths flowing. These are all the different current paths. Okay, if I consider one of the current path, I'll get the answer. Okay. So let me consider this current path. Okay. So I'm starting from here. I want the current path here. So tell me the current path. This is I by 3 into this. These resistances are all R. So I by 3 R voltage drop plus I by 6 R plus I by 3 R Z minus V is equal to 0, or V is equal to I by 3 plus I by 3 is 2I by 3 plus I by 6 into R. So if I take V by I common, so R will be R into, so if I take 6 as LCM, 4 plus 1, 5 by 6 R. So R equivalent is nothing but 5 by 6 R. Did you get it? Or shall I repeat it? Everyone should understand the logic behind it. Once you know the logic, it's a straightforward one. You should be able to find the logic behind it. Understood how I did it? I just use the logic that the current is getting equally divided. This is called the property of symmetry. So the current is getting equally divided. So for a symmetrical network, current gets equally divided for every node, and I took one of the paths and I wrote the KVL or the nodal mesh equation for that mesh, and then I got the equivalent resistance as the answer. Okay, is it clear? Shall I repeat? Shall I move on to the next question? Okay, clear, right? Moving to the next question. Yeah, again, this is a gate question. So everyone try to answer this. Read this, and write down the given data, and then try to solve the question. When a resistor R is connected to a current source, it consumes a power of 18 watts. When the same resistor is connected to a voltage source having the same magnitude as the current source, the power absorbed by the resistor is 4.5 watts. The magnitude of the current source and the value of R are. So read the question again and try to write down the given data and solve it. Any answers? Okay, I'm doing this. So when a resistance, everyone look here, everyone look at this screens. So when the resistor R is connected to a current source, let me call it current source, the resistor is connected. So connect value of R, I and R. So the power consumed is 18 watts. Okay, let the current source value of current source is X amperes. The resistance is R. So what is the power consumed here? So I'll call it as X amperes, and power consumed is 18 watts. So power equations for power, formulas for power in current and resistance. What is power? Tell me the
P is
equations for
equals
power.
to P is equals to I square into R.
Okay, what are the other equations? I square R and V square by R and V into I. Okay, so I square R. So I square R is equal to 18. I is nothing but X. X square R is equal to 18. This is equation 1. So what is the second part given? When the same resistor R is connected to a voltage source of same magnitude. So what happened here? So this is X volts, a voltage source is connected to the same resistor R. Then the power consumption is 4.5 watts. So this is V square by R. V square is nothing but, sorry, V square by R is 4.5. V is nothing but X. X square by R is 4.5. So you have two equations and two unknowns. Find the answer. I can replace X square as 4.5 R. In this, what happens now? 4.5 R square is equal to 18. So R square is 18 by 4.5. 18 by 4.5. 5. 4.5 fourths. So R is equal to 2 ohms. X is equal to 9 root is 3. So 3 amps and 2 ohms. B option. Okay. So X is 3 ohms and B is 2 ohms. Clear? Only thing is you need to read the question properly. You need to read the question properly and answer it. Okay. Is it clear? to the next one. So we'll solve a good number of questions, because if you are good in basics, then only we can go to the next topics. So I want everyone to find these two. Find the current through the 2 ohm resistor here. Find the current I in this problem. Two problems, two different problems. And here, and find the current I here. So if you have attended the last, to do it immediately, at least this one. So answer for this. Any So can you identify? Can you be able to identify what is the circuit? Anyone? If you identified the circuit, then the answer is straightforward.
I think I is 0.
0, right? I is 0. How?
It's a balanced Wheatstone bridge.
Yeah, this is a Wheatstone bridge. Able to like see it, if you can able to picture it. This is a balanced Wheatstone bridge. Okay, this is the central limb. So if I say A, B, C, D, okay, I'm drawing it. This is my 5-volt source. So A is 2, A there is 1 ohm, A to C 1 ohm, and D to B there is 1 ohm, and D to C there is 1 ohm, and this is 2 between B and C. So this is a balanced Wheatstone bridge. Whenever you see a Wheatstone bridge, the first thing you have to do is check for the balance of the bridge. If the bridge is balanced, the current through the central limb is 0. So answer is big 0 in this case. Okay, is it clear? Now do the second one. Now do this one. The previous year gate question. I think I missed a resistance here. Try solving this. The value of this resistor is 22 ohms. 22 ohms. Okay, now solve this. Solve this. Any answers? Somebody said 4. No. 2. No. So you considered this 22 ohms, right? I missed it previously. This is 22 ohms. Okay, let me solve this again for you. So can you see some series parallel combinations? Whenever I already told you, if you want to solve any circuit, you have to approach from this side only. So if you can see any series parallel combinations, tell me any series parallel combinations. 9 and 5 ohms. These two are in 9 ohms and 5 ohms are in 9 ohms and 5 ohms are in series, right?
Series.
9 ohms and 5 ohms are in series. So what will happen now? So this will become 14 ohms. 14 ohms, and I'm having a 14 ohms here. So 11 ohms. So can you tell me how are these 14 ohms and 14 ohm resistors? These two. 9 5 is in parallel with 14 ohms. Can you see this? 14 is parallel with 14. What is the answer? 14 ohms is parallel with 14 ohms.
7 ohms.
7 ohms, right? This is 18, this is 11, and this is 7. So 11 and 7 are in series. So this is again 18. 18 parallel with 18 is
9
18
ohms.
parallel 9 ohms. Again you have 13 ohms here and 22 ohms here. So what is the equivalent resistance? R equivalent 9
11
plus
ohms.
11 ohms, right? 9 plus 13 is 22. 22 parallel with 22 is 11 ohms. R equivalent is 11 ohms. So the total voltage is 44 volts and the total resistance is 11 ohms. What is the current? Current is
4
44 by
amperes.
11.
4
4
ampere.
amperes, right? 4 amperes. So 4 amperes is going here. Okay, 4 amperes is going here. So if you see from here, this is 22 ohms and this equivalent is also 22, right? So 22 parallel with 22, that's what we got. So this gets equally divided here 2 amperes, here is also 2 amperes. Again, if you see from here 13 ohms and this one, this is 18 and this is also 18, right? This is 18 equivalently. So what happens? This 2 ampere current will get divided into 1 ampere and 1 ampere. So the current I is 1 ampere. Understood? You can, otherwise you have to write down the node equations every point, or directly you can say this. See, this is what your 4 amps is. 4 amps is getting 2 amps here. 2 amps is coming here and it is getting divided as 1 ampere and 1 ampere. Okay, clear? Shall I repeat it? 7. No, not 7. So did people find any? So there are no Wheatstone bridges in this. I think somebody did in a different way. You should first try to see if there are any series parallel combinations. There are no Wheatstone bridges in this. Everything is series or parallel. So this is how you have to do this. So current is 1 ampere. Okay. Try the next question. Use source transformation technique. Find the current through the load resistance RL. Source transformation technique. I already told you in the last class about the source transformation technique. So use source transformation technique. Convert all the sources, like convert the sources in such a way that you'll find the current through the resistance RL. I'll give you a minute. I want everyone to solve this. Any answers? Okay, let me show you this. This is people. I've seen people doing mistakes on this. So everyone look at the screens. Everyone on the screens. So what I can do, I can convert this voltage source and current resistor into, this is a practical voltage source. So I told you source transformation applies only for practical voltage sources and practical current sources. So I need to convert this practical voltage source into a practical current source. Again, I can convert this one also. So we have to do it in stepwise. Okay, we have to do it in stepwise. So let me convert this one first. Okay, so if I convert this resistor and a voltage source here, I'll keep the circuit same. So what will be the current value here? The resistance value will be same. So what will be the current here? Anyone?
5 amps.
5 amps. Okay, 5 amps in series with, sorry, in parallel with, I'm sorry, I did a mistake here. A voltage source in series with a resistor replaced with a current source in parallel with a resistor. So this will be 5 amps and this is 2 ohms. This is 2 ohms and this is again 2 ohms. There is a circuit here. Okay, so how are these two? 2 ohms and 2 ohms? 2 ohms and 2 ohms are in parallel. So what is the equivalent resistance here? 1 ohm, right? So 5 ohm, 5 amperes in parallel with a 1 ohm resistor. And again have a resistor and voltage source and resistor. 3 volts and 2 ohms. Okay, is this clear? Now what I'll do is, again I'll convert this current source and resistor into a, so this is a practical current source. So I'm converting and simplifying this. So I'll convert this into a practical voltage source. Okay, again I'll convert this into a practical voltage source. So tell me what happens now. If I convert this, I'll get a positive, negative. See, the current direction, this is positive here and negative. If you see, this is my positive, so that is my current direction is this way. So again, positive, negative, and a resistance in series. Resistance value is 1 ohm. So again, I have a 3 volt source here and a 2 ohms. So what will be the value of the resistance? Anyone? V is equal to I into R. Okay, let me draw it here for you. So if I have a practical voltage source of value V and R, my conversion will be something like this. I and R. R will be same. Voltage will be equal to IR. And I is equal to V by R. Okay. So now tell me the value of voltage here. Voltage is nothing but I into R. So I is 5 amps, resistor is 1 volt, 1 ohm. So this will be a 5 volt source. So if you see this voltage source now, after the reduction, this voltage source is in series with this voltage source, and they are series aiding. So if I go through this circuit in this way, I'll get -5, and this is -3 volts. 3 volts. So these are in series aiding. So what will happen? This voltages gets added up. This voltages gets added up. So I'm drawing it here. So what happens? Plus minus 5 plus 3 is 8 volts. And the resistances are in series 2 ohms and 3 ohms. 2 ohms and 3 ohms is 1 ohm. So this will be, and the remaining circuit. There is a 2 ohms resistor here and a 4 volt source. This is my load resistance RL. Okay. Now further, what I can do? I hope everyone is looking. So again, this is a practical voltage source. I want to convert this into a current source. So if I convert this, I'll get a current source in parallel with a resistor. So this is a 2 ohms and I have a circuit here. So this is So tell me, this is 3 ohms. So tell me the current value, 8 by 3 amperes. Okay, so there is a 4-volt source and a load resistance. Again, so these two are in parallel, 3 ohms and 2 ohms in parallel. What is the equivalent resistance? 6 by 5, 1.2, right? So what happens, or let me keep, this will become again a practical voltage source series with 6 by 5 or 1.2 ohms. 8 by 3 into 6 by 5 is 16 by 5. 16 by 5 is 3.2 volts and a 4 volts load resistance of 10 ohms. Okay, if I see this, what is the current here now? So if I draw the loop equation here, minus 3.2 plus I into 1.2, 1.2x I, sorry, 1.2 I plus 4 plus 10 into I is equal to 0. So tell me what is I here? I is equal to minus 0.8 by minus 0.8 by 10 plus 1.2, 11.2. So tell me the answer. Are you able to understand it? So you need to keep some more concentration because this is an online class. You'll easily get diverted. Otherwise, you can ask me if you don't understand it. Yes, somebody wrote 0.07. Okay, just check the answer. Okay, I just want to show you the procedure. I think if you get the procedure right now. So this is a, because I want to tell you this because people directly convert this and this at the same time. You should not do that. You should simplify the circuit. So that's why you should use the source transformation technique. You should use the source transformation technique so as to simplify the circuit. Okay, so this is how I went through. This is the circuit. Okay, okay, is it clear? Shall I move on? Shall I repeat it? Clear? I'm waiting for responses. Is it clear? Shall I move on? Clear, right? Okay. Okay. So next topic is nodal analysis and mesh analysis. Okay. I want to start theorems today. Let's see. I don't want to go fast in the first classes. That's why I'm doing this. Okay. I want you to do more and more problems on this. Okay, so nodal analysis and mesh analysis. So nodal analysis, first thing is nodal analysis. What is nodal analysis? As I've written here, KCL plus Ohm's law. Nodal analysis is nothing but your KCL plus Ohm's law. Okay, so how do you do this nodal analysis? Select a node as a reference node, assign voltages V1, V2 and so on up to Vn minus 1 to the remaining n minus 1 nodes. Okay, you have to select a reference node, and for all the remaining nodes, reference node is usually taken as the ground node. Ground node will be the reference node. Okay, ground node is reference node. For all the remaining n minus 1 nodes, you have to assign the voltages, node voltages, and apply the KCL at the n minus 1 non-reference nodes. All the non-reference nodes, you have to apply the KCL use Ohm's law to express the branch currents in terms of node voltages. Remember, branch currents in terms of node voltages. Branch currents in terms of node voltages. You have to remember this. This is how you do nodal analysis and solve the resulting simultaneous equations to obtain the unknown node voltages. So if you use nodal analysis, you will get the voltages. Remember this. If you use nodal analysis, what will you get? You'll get the values of the voltages. So in a particular question, if you want to find the voltage of a particular node, it's better to use the what you call nodal analysis. If you want to find the current, it's better to use the mesh analysis. Okay, nodal analysis is basically to find the node voltages directly. After finding the node voltages, you can find the currents, but if you want directly to find the currents, it's better to use the mesh analysis. Okay, it's up to a person whether you can for a particular problem you can use both nodal analysis or a mesh analysis. But if you get two equations in nodal analysis instead of mesh analysis, three equations in mesh analysis, it's better to do nodal analysis. Also, both what you call both the equations, if you get two equations by doing mesh analysis or if you get two equations by doing nodal analysis, it's better to know if you want to find the current or voltage, you can decide by that way. Okay, how do you decide if you use nodal analysis or mesh analysis? You have to check how many nodes are there, how many unknown voltages are there, or how many unknown currents. If both are equal, then you should see what is my end result. If I want to find the current through a branch or the voltage through a branch, you have to do or voltage at a node. Okay, you have to like consider all this and then you have to apply nodal or mesh analysis. Okay, so example, if I take this, so this is a node. So tell me the node equation at this node. Anyone? So while writing nodal analysis, always remember this: branch currents in terms of node voltages. Branch currents in terms of node voltages. So these are the currents. What are the currents here? I1, I2, and I3. So I1 and I2, I1, I2, I3 are leaving currents. So I will take them as I1 plus I2 plus I3 as 0. I1 plus I2 plus I3 as 0. So tell me I1, current I1 in terms of node voltages V2 and V1. So if the current is in this direction, the voltage at this node must be greater than the voltage at this node. This is the assumption. If this assumption is wrong, I'll get the negative current. Okay. So, but you always follow the current, the one node, one what you call reference. So always take the leaving currents. Okay, always take the leaving currents and write the node equations in with respect to the leaving currents. So what is the leaving current here? V2 minus V1 by R1. V2 minus V1 by R1. Understood? The current here is this voltage minus this voltage is the voltage across this resistor. So divided by the resistance, you'll get the current I1. So similarly, tell me what is I2? Tell me I2. Tell me I2. I2 is
V2 minus V3 by
V2 minus
R2.
V3 by R2. Again, I3.
V2 minus V4 by I3.
R3. Okay, is equal
Sorry,
to
R.
0. Yeah. Okay, this is how you write the node equations. Okay, this is how you write the node equations for a particular node. So always remember node currents in terms of, sorry, branch currents in terms of node voltages. Okay, is it clear? I'm moving on. Next concept is something called as supernode. What do you mean by a supernode? Supernode is formed by enclosing dependent or independent voltage source. If a dependent or independent voltage source is connected between two non-reference nodes and any elements connected in parallel with it. Okay, remember a supernode is formed when a voltage source, either dependent or independent source, is connected between two non-reference nodes. Non-reference in the sense non-zero nodes. Okay, non-zero or non-ground nodes. Then a supernode is formed, and also any resistances or any elements in parallel with this. In this example, if you can see, this is a voltage source. It is between two what you call non-reference nodes. Two non-reference nodes. Okay, two non-reference nodes A and B. So there is a voltage source between two non-reference nodes. Then you'll consider them consider it as a super node, and you'll neglect this while writing the equations at these nodes. Okay, while writing the equations at node A and B, you'll combine them, neglecting this resistance, sorry, this voltage source, and then you'll write the node equation, and then you'll write the super node equation as follows. Okay, then if there is a resistance with this, you'll neglect that also. Okay, I consider super node while considering the super node. Okay, I'm writing the super node equation here. So this is my plus minus A and B. This is Vs. Okay, this is how I'm having the circuit. Okay, these two are A and B are non-reference nodes. Okay, so we'll have a Va here and Vb, voltage at this node and this node. So what will be the when I say this is a voltage Va, this is with respect to reference voltage, reference as ground, taking reference as ground. So this is my Va. And again, if I consider Vb, so this is A, this is B. So this is again Vb is again with respect to ground. So this is positive, negative, positive and negative. So now, so the grounds are connected. If I take the loop here, so this will be minus Va plus Vs minus Va plus Vs plus Vb is equal to 0, or Vs is equal to Va minus Vb. So this will be my super node equation. Okay, this will be my super node equation. You'll get this clear when we do some problems. Okay, so this is clear, right? I can write Vs is nothing but the voltage at this node minus the voltage at this node. If this is positive and this is negative, this is Vs is equal to Va minus Vb. Okay, this voltage Vs is equal to Va minus Vb. Okay, is this clear? So this concept people gets confused. That's why I want to be clear on this. So supernode is nothing but whenever a voltage source is there between two non-reference nodes, that voltage source and anything in parallel with it can be what you call considered as a supernode and can be neglected while writing the equations at these nodes. Okay, and the supernode equation is this. This is what you'll call it as a supernode equation. Okay, and this is about nodal analysis. We'll do some problems on this. Next, mesh analysis. Okay, as I told you, nodal analysis is nothing but KCL plus Ohm's law. Mesh analysis is nothing but KVL plus Ohm's law. Okay, again, so again assign mesh currents I1, I2 and so on up to IN to the n meshes. Okay, I1, I2, so on up to IN to the n meshes. Apply KVL to each of the n meshes. Use Ohm's law to express the voltage in terms of mesh currents. So again, important, voltage in terms of mesh currents. Voltages in terms of mesh currents. Okay, voltages in terms of mesh currents. Solve the resulting n simultaneous equations to get the mesh currents. Okay. So voltages in terms of mesh currents, this is important. KVL plus Ohm's law is nothing but your mesh analysis. Okay. Again, similarly, why super named so? Why super named? Because see, super is that's why if you have a voltage source, you can't write a node equation here. Why? In the sense, let me explain this. So if I have a node here, VA, so can I write VA? I can't write the currents here, right? I can write here current as VA by VA minus 0 by R2. Here also I can write VA minus some V1 by R1. But I can't write the current here. That is why if there is a voltage source in between two non-reference nodes. So this is a non-reference node and this is a reference node. So I don't have a problem here. But if this is a non-reference node and this is a non-reference node, that's why I got a problem. That's why you call it as a super node. Why super? In the sense, I will combine these two nodes and there will be only one equation for A and B. For nodes A and B, there will be only one equation. That is why you call it as a super node. Okay, there will be only one equations for A and B, only one equation, nodal equation. Is that clear? Okay. Okay, I'm moving to mesh analysis. Okay, mesh analysis, as I explained, voltages in terms of mesh currents. Next, super mesh. Okay, let me draw a circuit. This is V1, V2, R1, R2, and R3. Okay, so help me doing this. This is my meshes. I have two meshes, I1 and I2. So what I have to do, I have to write voltages in terms of mesh currents. So all the drops in this mesh, I have to write in terms of currents. So in this, if I call this as A, B, C, D, E, and F for mesh 1, mesh 1, I'll start from A, B, C, F, and A. A, B, C, F, and back to A. So this is my mesh 1. Okay, starting from A. So tell me the voltage drops across every element. So this is my minus V1, minus V1, minus V1 plus this is the current here is current in this branch. Current in this branch is I1 into R1. So current is I1 and the voltage will be I1 into R1. So this will be my drop, I1 R1 drop. And the voltage drop here is I1 minus I2. I want the voltage in this direction. So I1 minus I2 into R3. I1 minus I2 into R3. Okay, is equal to 0. So this is for mesh 1. Okay, so I can write V1 is equal to I1 into R1 plus R3 minus I2 into R3. So this will be equation 1. Okay, so for mesh 2, starting from, I'll say from D, I'll start from D. So mesh is closed loop, right? D, E, F, C, and D. D, E, F, C, and again D. Okay, D, E, F, C, and again back to D. So starting from D, if I go in this way clockwise, I'll encounter plus V2, then minus. So here, what happens? So I'll get I2 minus this current. This current is like this, right? So this current will be I2 minus I1. I2 minus I1 into R3. I2 minus I1 into R3 plus this current here. This current is I2 into R2 is equal to 0. Again, V2 is equal to minus I1 R3 plus I2 into R2 plus R3. Okay, so this is my equation 2. So I can solve these two to get the values of I1 and I2. So is it clear? So this is how you write down the mesh equations. Any doubt in this? Because we will be directly doing the problems again. See, again, I want to tell you, so I'm taking always the clockwise directions. Some people take one mesh as clockwise, the other as anti-clockwise. You can do whatever way you want, or both you can take as anti-clockwise, but uh, uh, we should not get confused. That's why I always consider but clockwise direction. If I have a dependent or independent current source, okay, see again, as I told you, in case of super node, what I said, any connected in parallel, any elements connected in parallel can be what you call neglected. Similarly here, any element connected in series, if I have a resistor in series, that can be neglected. Also, any elements connected in series can be neglected. Okay. Because the logic here is, because the whatever the current this source is forcing, the same current will flow through the resistor. Okay, you don't have to write a separate, you don't have to find the separate current, because this source will force the same current. If this is a 3 amp source, if I have a resistor, that will be the same. Same way in this, what you call super node, if there is a voltage source here, voltage source and a parallel resistor, whatever the voltage across this source, the same voltage will appear across the resistor. That is the logic. If there is any connected element in parallel with it, you don't have to consider it, because the voltage across that element will also be decided by that source only. Okay, here series. Okay, so again I have R1 and R2 super mesh. What I'll do is, okay, I'll consider this as I1 and I2. This current is given as some I amperes. Okay, this current is given us some I amperes. So at the super, what you call super mesh, this is I amperes. This current is I1. This current is I2. Or otherwise, can you tell me at this node equation? This node equation is all the incoming currents. What are the incoming currents? I1 is coming. So I1 is equal to, sorry, it got disconnected. So at this point, I1 is equal to I plus I2, or I is equal to I1 minus I2. This will be my super mesh equation. Okay, super mesh equation. Why super mesh again? So I can't write the what you call current in terms of current sorry, voltage drop across this current source. That is why I'm taking a super mesh. I can ignore this current source, and I can directly write the mesh equation directly, super mesh equation. We'll do it when we'll get in the problems. So super mesh equation can be written like this: I is nothing but this current, I is nothing but this current I1 minus I2. Okay, I1 minus, this current is nothing but I1 minus I2. Okay, that is your super mesh equation. Are we clear so far? Let's do some problems if the time permits. I think I was late by 10 minutes. I should get 5 to 10 more minutes. Okay, we'll do some problems now. If this concept is clear, I want to move on. Is it clear? Once more. Okay, once more regarding the super mesh. Or the mesh equation. See, super mesh is nothing but, so if I have a current source, by either dependent or independent current source between two meshes. So I have two meshes here, mesh 1 and mesh 2. I have a current source here between the two meshes. Then I'll consider it as a super mesh. I won't consider this current source, and I'll write the loop equation directly. Okay, so now I need the second equation. For the second equation, I'll consider this super mesh equation. Super mesh equation, I can consider the current node E here Tell me the node currents here. This is I1 coming. This is I2 here. Okay. So tell me the node equation. This is I here. So I1 is equal to the leaving currents I plus I2. So I will be I1 minus I2. Okay. I is nothing but I1 minus. Please give an example for dependent sources of current. Yeah, we'll do it in problems, not a problem. Dependent source is nothing but, see, if I have a dependent source here, so let me say this is a voltage dependent current source. So 3 times V. So V is somewhere, this is my this is my voltage V across this resistance. So I will write the equation in this in terms of this. Okay, this current source value will be 3 times V. Okay, we'll do it in problem, not a, when we'll do some examples, then you'll get it clearly. Okay, okay, I'm moving on. So this is a problem. Find the node voltages at 1 and 2. Find the node voltages at 1 and 2. Use KCL, sorry, use nodal analysis and do this. Find the values at 1 and 2. Okay, let me solve this for you, and I want you to do the next one. Okay, at node 1 and node 2. The networks is an interesting subject. I don't want you to consider it to be like I'm taking more time. So because for networks, we should at least have a stretch of time, and not 2 hours. Is if I tell you the concept today and if I tell you some examples on the next class after 3-4 days, it will be difficult for you to correlate it. That's why I want to complete some more problems today. So please cooperate it. If you don't want, you can just chat, drop a message in the chat. I'll stop it. Okay. So what do? So mesh equations. What I'll do is, sorry, node equations. I'll write this as V1 and V2. Okay. V1 and V2. Tell me the mesh equations here. All everyone write down the mesh equations. So at the mesh 1, tell me the currents in terms of voltages. Tell me the currents in terms of voltages. So I'll take all the leaving currents here. So leaving current here will be -1. The leaving current here will be V1 by 2. Leaving current here will be V1 minus V2 by 6 is equal to 0. Okay, so if I simplify this will become V1 1 by 2 plus 1 by 6, 4 by 6, right? 1 by 2 plus 1 by 6. Okay, minus V2 by 6 is equal to 1. Okay, or if I can take 6 as LCM, what will I get? V1 4 by 6, 4 4v1 minus v2 is equal to 6. So this is equation 1. Similarly at node 2. Node 2, tell me the leaving currents. See, always I'm considering the leaving currents. V2 minus V1 by 6. V2 minus V1 by 6 plus V2 by 7 plus 4 is equal to 0. Okay, again minus V1 by 6 plus V2 into 1 by 6 plus 1 by 7 is equal to minus 4. This is second equation. Solve equations, find the values of V1 and V2. So tell me the answers. Are you able to understand this, right? So this is important. Is it clear? V1 is 2.2 and V2 is no, V1 is -2, V2 is -14. -2 and -14. So these are the two equations. You need to solve this. Okay. Okay, shall I move on? These are simple equations. I hope you all can be able to solve these. I'm giving you with the answers. If you don't find it, you can what you call, you can send me in the WhatsApp group and get the answers. Okay, solutions. With your calculators, I think if you write down these two equations and if you enter these two equations in the calculator, you'll get the answers directly. Okay, moving on to the next question. So find the voltage V and current I. Okay, shall I repeat the equations? I just want to write down the equations. I want you to solve the problems. Okay. Okay, I have lots of problems from the gate also. Okay, shall I continue with this problem or the previous problem? Or shall I stop? Okay, no response from anyone. Okay, I'll do the last problem, okay, for the day. Am I audible to you all? Okay, so okay, the last problem, okay, won't take much time. So this is I just want to like do the problems on the topic we have covered at least. That's what my intention is. So I need to find the voltage and current. So again, I'll use nodal analysis V1 and I'll call it as V2. Okay, V1 and V2. So there is a voltage source between two nodes, two non-reference nodes. I'll call this as a reference node. Okay, two non-reference node. What method shall I use? A voltage source between two non-reference nodes. Voltage source between two non-reference nodes is a super node, right? Super node, yeah. Okay, this is a super node. So how do we do this? I am writing the node equation at node 1. Node 1. So tell me node equation V1. So this voltage will be 21. 21 with respect to, so the potential here is 21. So I need to take the leaving currents, right? Leaving currents. This is a super node. I'll neglect this. So leaving current here is V1 minus 21 by 4. V1 minus 21 by 4 plus V1 by 3. V1 by 3. Okay. Then again here I need to neglect this. So again I need to consider the equation from here. So again I need to write down the leaving currents V2 by plus V2 by 2 plus V2 by 6 is equal to 0. So you understood what I did? I combined 1 and 2 nodes. Because it's a super node, I have to neglect this. I need to combine these two nodes, and I wrote the equation at node 1 as the direct equation in terms of V1 and V2. So V1 by minus 21 by 4, V1 by 3, and V2 by 2, and V2 by 6. This is your super node equation. Sorry, node equation. So this is one equation. So what you'll get V1 by 4 plus V1 by 3 V1 by 4 plus V1 by 3 plus V2 by 6 plus V2 by 6, sorry, 2 is equal to 21 by 4. 21 by 4. Okay, so all this sorry, you will get equation in terms of V1 and V2. You will get equation in terms of V1 and V2. This is equation 1. And the other equation, I need to write the supernode equation. I already told you how to write the supernode equation. Can someone tell me the supernode equation at this? Supernode equation. Can someone tell me the supernode equation?
V2 minus V1 equals to 9.
Yeah, V2 minus V1 is equal to 9. V2 minus V1 is equal to 9 is the second equation. So you have two equations, two unknowns, solve for V1 and V2. Solve for V1 and V2. Understood, right? V2 minus V1 is equal to 9. This is 9. Again, plus V2 is equal to 0. V2 9. Okay. These are the two equations, two unknowns. You'll get the answer. If after finding V1 and V2, what is V and I? Tell me what is V and I? How do you find V? What is V?
V is V1.
Yeah, V is directly V1. Is directly V1. How to find I?
V2 by 2.
Yeah, V2 by 2 is I. Okay. This is how you find V1 and V2. Okay, in the next class, we'll do some problems on mesh analysis and super mesh, and then we'll do some gate problems, including dependent sources also. Okay, then we'll go for theorems. Okay, then we'll go for theorems. Is this clear today? Or any doubts in so far in this class? Giving, yeah.
Sir, in source transformation technique, you mentioned like practical sources.
Yeah.
So what is that? What does that mean? Practical sources means.
Yeah, practical source means. So yeah, okay. Let me have an empty page. I'm deleting it. So practical voltage source and practical current source. I think you were not there in the last class. There are two sources: ideal source and practical source. Ideal source is nothing but the internal resistance will be 0. So this is an ideal voltage source, whereas a practical voltage source will have a series resistance with respect to the source. This is called a source resistance or the internal resistance of the source. Okay, every practical source, every source in practical practice or the practical you do, it has some resistance. Okay, so that internal resistance will be in series with respect to a voltage source or a current source. What happens? In case of current source, you'll have a parallel resistance in parallel with the current source. So this is a practical voltage source. This is a practical voltage source, and this is a practical current source. So practical voltage source can be converted into practical current source, or a practical current source can be converted into a practical voltage source. This is called a source transformation technique. Okay, this is called as a source transformation technique. Understood?
Yes, sir. Thank you.
Yeah. Okay. Any other doubts? Shall we conclude? Okay, I'm concluding and hope everyone are following it. Next, I want you to do some problems or from gate or practice from some source. Otherwise, I can give you some assignments. If you are thorough with them, we can go on. Okay, at least do problems from the concepts covered so far. We'll be doing more on theorems than the transients and all. So far I think these concepts, if you are clear with these concepts, the next topics will be easier. Okay, thank you again.
Thank you, sir.